Welcome everybody, my name is Ochiniwa. I am a Twitch streamer. I do this for pleasure. I have a lot of fun doing it. If you want to see more of this, don't hesitate to go and watch my profile. If there's enough interest in this video, I will make more of those, but we will see. What is the purpose of this video? The purpose of this video is very short, give you a quick introduction into the basic tools of the automation in Shapez 2, give you some ideas about how to do this and how the different tools work. I will introduce the basics of a MAM. I will not go through the details of a MAM. I will not give you a final build because I haven't finished it myself, but I want to give the people out there the idea of how this could work and how this may work. I am pretty sure there's going to be some fantastic builds, some crazy builds, some ludicrous, completely crazy builds, but okay, this is just the basic. The video will be separated into three elements. The first one is I will go through the basic tools, explaining how these tools work, giving you some ideas. So disclaimer, I am not a professional. I have of this art, I've discovered it myself. Also, this game is in early release, so this might change. There might still be some bugs. I kind of saw a tiny bug, or I don't know really 100% how the emitter and receiver work. You will see that in the description of the basic tools. The second part is to give you a basic use of the tool. So what would you need to do with a shape to analyze it and decompose it into its elements and colors. So that is the basic use. Second part, you can click on the video immediately to go that part. The third part is going to be a practical build. So I'm gonna go more in detail of how this build is done, and then basically show you how this build looks like, and then go over into a concrete and practical use of, okay, how does this now translate into building or having the initial elements of building a make everything machine. And we will stop there. So there's that's the last part. I'm not going into the automation of colors. I'm not going into the automation of pins and crystals. If there is enough interest, and if I myself get around to these and understand these and are able to use these, I will then come back and maybe give you a little bit more detail on that. So that's about the video. So much about the introduction. Let's get rolling into the first part. Okay, so let's jump in. We will start with just basic tools. The objective of this part is to understand what are the tools that are given to you by the game and how do they work. Now again, this is as of today. It might change in the future, but if it does, I will consider amending the video. So let's start straight into. So if you know the tools, you can skip this part and you go directly to the next part, which is the implementation of these tools and the use of these tools. So I've prepared a small setup here, which basically goes through all the tools. And these are all the tools that are basically here: the wire, the display, the signal producer, and so forth. And the idea here is to go through all of these and explain what they are. We will start with the cable. The cable is pretty straightforward. However, there's something slightly important to know about. So the cable is basically the signal or the wire which you find here. So it's just a wire. If it is active, it will be light green. If it is non-active, it will be dark green. So this wire can transmit either the shape so it can transmit a whole shape. So here I've used another tool, the signal producer, which just produces a signal. You can configure it. You can either say it as null, as a conflict, it can be a number, it can be a color, or it can be a shape. So in this case I took the shape, circle, 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 star, uncolored, and this is basically the shape you see here. So this signal emits that shape. Now this whole goes through, and this is the other tool, which is a display, which you basically use to put it anywhere on a cable to see what is currently inside that cable. So you can take it and you can put it and then attach it to any cable, and it will tell you what is the signal that goes through. We'll come to this later. So it can either transmit a shape, it can transmit a number, it can also transmit a color. So you basically can say color red or color blue, and on the other side you will have a color coming out. Now if I were to colorize this sign here, now it obviously will transmit both the shape with its color. So you will see here it is blue, so it will transmit the whole shape, and it will even transmit the whole shape if you make this a multiple layer. So yeah, that was of course wrong. So if you make this a multiple layer, it will basically transmit the whole shape. Okay, so the last one is basically a signal that can be transferred to the wire, which is just an on-off. So if I toggle this on, it will transmit and it will say 1, meaning the signal is on, or it will transmit a null, meaning it shows nothing, means there's no signal, there's nothing in here, so the screen goes dark if there's nothing going through at all. Now we have also in the wire, we have this small wire transmitter, which is nothing else than the same for a jumper here. So if you have a belt, you can basically jump from here to here, and here the same, the wire will transmit from here to here. Now the wire has one last element which is specific to the wire, which is this cross. So you can basically have, if I take this and I put it there, so you can basically now cross the wires over each other without needing to go to a second layer. To remember here is it can transmit shapes, it can transmit numbers, it can transmit colors, or it can be used as an on-off. The next tool, which is very important in the game, is the global transmitter. So the global transmitter will take anything that goes in and it will transmit it all over the map. So anywhere in the map, you can go as far as you want. If you basically put a receiver, so this is the receiver, it will, if they both send on the same channel, so I chose here channel 3 cyan, so if I take a signal that goes in this case this shape, and I transmit that on the cyan channel, now if I put down a receiver, and it will output that shape. Let me give you an example. If I take this away, he immediately stops receiving that. Now I'm gonna link that in. So obviously this is a 1, so he transmit everywhere 1. Let me put down here another, and we take this is the green receiver. Nothing is being transmitted on green. Now if I switch this to green, you will see this becomes 1. Now important is this one stays unchanged. I don't know if this is a bug or if this is wanted. It is a kind of weird behavior I noticed, because if I put down another receiver and I would transmit in this case a blue color, so let's take the blue in there, the green, so if I put this to cyan also, this one will become blue, but this one switches back to the 1. So This is green. Now if I put this one on green, in this case the green signal both is being transmitting the number 1, so the button on. So if I toggle this, and it's transmitting a color. Now the color is being shown and not the other one. So this is a bit of the question of priority. What is he transmitting? So here he is not transmitting anything. Again, there should be a conflict here. So if I take this away, then you will see that he again takes up the 1. So important to notice here is the channels here. So what is he transmitting? On what channel? So if I go back to cyan, this becomes 1. You can also on the global receiver, you can choose as channel random operator 1 and random operator 2. So the random operator 1 is basically when you are pushing your operators levels. At the end of your milestones, you will receive 2 random shapes to build. So here what happens is, if you build 1,000 of these shares, the shape here will change. So instead of a previous milestone shapes, this goal requires a different randomized shape every level. So every time this goes up, there's a new shape. And the higher you go, the more complex it gets. And here it says you can either build it manually or try to build a factory that automatically produces any given shape. So what they call a make anything machine, what this video is mainly about. So you can place as many receivers as you want and as many senders as you want, but remember the conflict between the senders if they have the same color. And now we're gonna have a look at the belt reader. Okay, so the belt reader basically is a tool which you can put anywhere on a belt. So if I take the belt reader and I put it here, it will do 2 things. It will basically count the flow of shapes going through. So if I basically just cut this shortly and then start again, see, it goes down to 72 average, but then jumps to 180 again. The advantage of doing this is that you can see if your factory produces a full lane or not. So you just put a reader on it, and then it will give you the ability to see, okay, is this a full belt? Also, what I find quite interesting, if you rotate the map, the reader will always be on the same alignment. It will basically always be readable. So coming back to the receiver, it will the reader, so the belt reader, it will basically read the throughput, but it also reads the shape that is on there. So you see here there is a small link. So if you attach a screen to it, the screen tells you what is actually the shape that goes through. So you can read out what is going on a belt. Okay, so the filter basically works in a very particular way. You can put a filter down and then it's like an alternative. Here I just put a button. Okay, so the button is off, meaning don't let anything through. He will basically stop the belt, nothing goes to the left and nothing goes straight. So it just basically says don't let anything through. If I switch this on, he lets it through. So that is just a way for stopping or letting a belt run. The second possibility is you can basically compare the belt. So here he sends in this shape, and this reader checks, is the shape that is coming through here, is that the same? If yes, he lets it through. If no, he basically deviates it. So here he makes a comparison, and if the comparison is true, he lets it through, and if the comparison is untrue, he basically deviates it. While here he doesn't do a comparison, he just switches on or off. So you cannot deviate like this. So that's about the belt reader, so again reading out the throughput and reading out what is on the belt. Now the other one is the belt filter, which basically can be configured to either stop the flow or deviate it. So let's dive into all these logical gates. So we have the AND gate, the OR gate, the NOT gate, the XOR gate, the equal gate comparison, and the gate just short. It is more or less as it explains, so it is a very basic logical system. The AND gate says if both signals are on, you let something through. Okay, so this one and this one needs to send a positive signal, and only then will you let it through. Okay, so if I were to take a shape, okay, and the shape, it will basically say there's a signal, so it is true. Now if these shapes don't match, he still shows a 1. And this is important, where the wire here changes its purpose. Here basically in this wire, the signal that goes through, and I can illustrate this by putting a screen here and connecting these. So basically here inside the signal is the shape, and inside this signal is also a shape. These shapes are different, but basically it's a shape. Now this one doesn't check if these shapes are equal, it just checks, do I get a signal? Yes, it's green. Do I get a signal? Yes, it's green. So both are positive, and that is an AND positive goes through. So no matter what type of signal comes through here, I could even here take a color blue, confirm. So I send in a color, I send in a shape, so he says I get 2 signals, both are positive, so he gives a signal through. Now the OR gate is pretty simple, so he will basically say, do I get a signal from either side? So I switch this on, I switch this off. So if there's a signal coming from here and this or a signal coming from here, like it says or either here or here, then he will say let it through. So OR gate. The NOT gate is just inverting whatever you send through. Again, just to be clear, if I take a color, okay, so a color, he will not send an inverted color, or if I take a shape, he will not send through a NOT shape, because that doesn't make sense. He will just say I get a signal and then I output no signal. Here there's no signal, I output a signal. Now the XOR is pretty simple to explain. So it basically says if I get a signal from one side, let it through. If I get a signal from the other side, let it through. So that's the same as the OR. But if I get a signal from both sides, don't let it through. So it is like, it's a combination of the OR and the AND. So if I get a signal from here, it's on. If I get a signal from here, it's on. But if I get a signal from both sides, it's off. The comparison is a little bit more complicated, or more sophisticated, not necessarily more complicated, but more sophisticated in the sense that it will compare whatever comes in. So here, if the signal is on, the signal is on, this signal is on, so it compares. Are these two signals identical? This one is on, this one is on, so now it's off. It even says on the signal off, on, off, meaning this one is off, this one is on, so the two signals are not equal. Now here, this signal is a shape, and this signal is a null. So if I take another shape, or if I would say color blue, okay, so this signal is a blue color, this signal is a shape. Are these two signal identicals? No, this is blue, this is shape. So okay, even if I take this shape and make it blue, So I have a blue shape, I have a blue color. No, they are not the same. Now if I take these, then of course both signals are the same. He says no, the signals here are the same. Now the gate basically takes the signal and it lets it through if this one is on. So if I basically toggle this, it lets the signal through or not. So again, here I could just put a shape. So it doesn't check the nature of the signal, it just checks, is there a signal coming in? So be it a shape, be it a color, be it a 1 or a 0. So I could just put back the button, if I just a button, so it will let the signal through if there is a sign coming in. So that's the gate. So this one gets the random shape. So the signal, I read it out here on the monitor, that is the shape, which is the random number 1. So to show you, if I go to random 2, he will take the crystal. Okay, now there is different tools here. This one is a simulated rotator, means it will take this signal and it will rotate it once clockwise. So this shape becomes this one. If I were to rotate it twice, 3 times, 4 times. So every time I rotate it, it becomes a new signal. So just to rotate the signal. This one simulates the half cut. So it will basically cut off the left side of the shape. So again, if I rotate this, you will see it would always cut off the left side. This one, and that is the unstack. That's a tool that is only available in the wires, and it will basically unstack the signal. Now the unstacker, what exactly does it do? The unstacker takes in a signal and puts out 2 signals. The first one is the upper layer. So the upper layer is these 2. So if you look here at this shape, the upper layer is these 2 and the other layers below. So there is these layers that are below. The next one is the paint. Well, it will basically, you will tell them the color and it will paint the upper layer like a normal painter would do. So if I would say paint this blue, so it takes the signal and tells me, okay, make the top blue or make the top white, whichever you need. So that's the paint. The crystallize is pretty straightforward. Also, you tell him to take the shape and crystallize. So obviously he will here crystallize 3 colors, 3 layers, and you just need to tell him here what color you need. So if you want this in white or you want this in yellow, whichever color you prefer, he will basically paint that in, well, not paint it, he will crystallize, then he will simulate the crystallization. And the next one is the simulated half swapper, which is pretty straightforward. He will take this signal and this signal, so these 2, and he will swap them. So you see he takes these crystals and he puts them on this one, and he takes these ones and puts them on here. This one is the stacker. He will basically stack this here, this shape, onto that one. Now obviously crystals cannot be stacked, so that's why the crystals here disappear. So what is left over is just these 2 half circles, quarter circles. So this half circle, we'll put it onto that one and obviously be then onto here, so that's the final shape. Okay, and then we come to the last item, which is actually the most important, one of the most important ones, or one that is quite important when you talk about doing a MAM. It is the shape analyzer. Now it is very important to understand what this analyzer does. This analyzer outputs the shape type and color of the northeast first layer quarter. What does that mean? So if you look here at your orientation, this is north, this is east, so the northeast. So he will take this shape and he will take the first layer. So if I look at this one, the northeast is here down, so it's the blue star shape. So, and he will tell two things. He will first tell us what is the color of that shape and what shape is it. So here the color, here the shape. And of course he just tells us the shape. So it doesn't tell us it's a blue shape, it just says here it's a shape. So gray and this uncolored. And here this is the color. These are all the tools that you basically will find in the game. Okay, let's get to the second part of this tutorial or explanation, which is basically what do we do actually with all these tools, or how can we use these tools to produce a make anything machine, so a MAM. And although we will not do a MAM here immediately, we will nevertheless try, or I will at least try to explain you how you can get to it. So the first thing you need to do is, if you have a shape, you need to decompose the shape into its different elements so that you understand what is actually in that shape. So I took in this particular example a shape that is not too complex. So what I didn't include is pins, and I did not include crystals. The reason is that at this stage I just want to go through the basic and understand how we basically can read this out. So we have this shape, which I basically just set up, which goes into this transmitter on the channel 5 yellow and is being received here on channel 5 yellow. So the signal that comes out is a shape, the same as goes in. So my objective here is, like, for the 5 layers, clearly explain on every single layer what is the shape on the northeast, northwest, southwest and southeast, and what is the color. So the first thing which we're going to do is we need to isolate the first layer up here. So we have this tool which is the unstacker. So we take the simulated unstacker, let's put it here. Okay, what does the unstacker do? So I can basically take this away for now. So the unstacker gives us 2 signals out. So it tells us what is the upper layer and what are the other 3. Now if I take this signal here and I do this again, I'm just gonna make it a little bit. No, I need to, yes, I need a cable here. Okay, so the next layer is this square. Let me put it here. So the next layer is the square and the other 3 layers are here. So we're gonna repeat this once more. I can just basically copy paste this up and up. Okay, so here we see the first layer on the bottom is this shape. The second layer on the bottom, on top of that one, is this, and then this, and then this, and then this. So that's the powerful tool, the unstacker. It basically cuts the shape into its 5 elements. Okay, so the next step, I'm gonna just take one of these shapes and decompose that shape into something different. So in order to do that, I'm going to slightly change this shape here so that we can better see the result. I just take this random shape. I hope it is correct. Confirm, yes. So now we end up with the last shape being this one. I took specifically 4 different shapes with 4 different colors to see how we best analyze that, but it applies to any of these, and afterwards I will just cut and paste the signal and you will see. So now I would like to decompose this signal. So we take it, let's take the signal here, so it's still the same, and we're gonna analyze this. So I take the analyzer and I'm gonna put the analyzer right here. I take the signal out and then see what does he give me. So he tells me that this corner here is a quarter circle blue. Okay, now the question is, what about the next one? So how can I see what is on the top left? So I take this signal and I'm gonna rotate it. So I take that shape, I take this tool, and I'm gonna rotate it once. Okay, now I'm gonna analyze that again. Now obviously I don't want these to connect. So the next one, so I've rotated this. So if I look at the signal here, what is this sign now here? So I've rotated it once, and now I see, okay, this one is now this shape in gray. So let me copy paste this over. There. And once more. Now obviously I need to take away this screen here because I need to let the signal through. Okay, so here now we have analyzed this complete shape and say, okay, the northeast is this quarter square blue, the northwest is this inverted circle gray, the southwest is a yellow star, and the southeast is a green square. So this is how we have decomposed this whole sign. Now we can do that with any other one. So if I take this one, he will obviously say these are all squares and this is the color. So it's basically gray, blue, blue, gray. So the next one would be star, 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 and it would be gray, red, red, gray. So if I take this one away, I would need a little bit of space here, so I need to take this, and he will also tell this. I take the shape, I analyze it, so the northeast is a blue color. I rotate it, the next one is a green, then a yellow, and then a red. So I know this shape is blue, green, yellow, red. Okay, so I have here identified the signal blue, green, yellow, red. So, and I know this is the northeast, northwest, southwest, and southeast. So it doesn't tell me that, but since I've rotated here, I know that is the case. So if I keep on the same logic, it will always work. So now in terms of the shape, I will basically go around here and I will go to and analyze here what type of shape is it. So I take the comparison here. Okay, so the first one is analyzing the northeast. So I will say I'll take the northeast and I say here as a signal emitter I'll take the square. So I say, is the northeast a square? Yes. So is the northeast an inverted circle? No. It's a circle? No. It's a star? No. So it is obvious that it can be only one of these. So here I take the signal, so this is the first one. Now I rotate it once and I read it out again. So if I look specifically at this shape, what is he showing me now? Now he tells me this is a circle. Now there's two possibilities here. So I chose one, so now I'm going to rotate it 3 times again, which means I rotated it once, the signal is red once, then it is red. Okay, so it's going to be this. We know because this one only reads the northeast, it never reads anything else. So I first read what it is and then I rotate it 3 times. 1, 2, 3, so it will be on the northwest, which basically is its original position. So I rotate it 3 times, so after here, if I go up, it's on the right side. And now I say, okay, square, no. Is it inverted circle? No. Is it a circle? Yes. Is it a star? No. So obviously it's one of these 4, so in this case it is a star. Now I take the original signal here, so if I go up here, so now we know it is an inverted circle. Now this inverted circle is on the southeast, so southwest, so I need to rotate it twice, this signal, so to put this again on the right side, and then I'm gonna do the same again. Is it a square? No. Is it a inverted circle? Yes. Is it a circle? No. Is it a star? No. So it basically tells me what it is. Last but not least, I take it, rotate it again, and do the same analysis, rotate it once, and then here I know it's star. So if I look at this matrix, which I have here, if at the end we look here, northeast is a square, northwest is a circle, southwest is an inverted circle, and southeast is a star. So by doing this, I basically have analyzed the whole shape and cut it into 16 different signals, whereas only 4 of them matter. And if I add these 4 signals, I also know their color. So northeast is blue, northwest green, yellow, red. So if I go counterclockwise, these are the colors. So I have decomposed the whole shape into its basic elements. This is of course a little bit too big, so takes a lot of space, so I try to compact this a little bit to make this more easable to see. If we look at this now, so I would say the first one is, so here it's a square, the second one is a circle, the third one is a inverted circle, and here this is a star. And if we look at this shape, circle, square, inverted circle, star, so it's correct. And the color also, first color is blue, green, yellow, red. So here we have the elements to decompose the shape. So that's the, I would say, the basic of doing MAM is understand these basic operations of how you can analyze a shape. Okay, now I would want to come back on a practical example of how this can be put in use. Now it is important to notice that this is one way to do it. I am pretty sure there's many ways to do it, there's very different ways to do it. My objective here is not to give you the best example of how to do it, but to give you the tools to understand how it could be done, and then let you find out yourself or figure out yourself how you would actually best want to do this. Now obviously what I want to analyze is the top layer. Here we see the lower layer, which you can see here underneath, and here the top layer. So we're going to focus on the top layer. On this particular case, we're only going to look at all the circles that are in this shape and where the circles are. So I take this shape and I analyze, and I say, what is on the northeast? Now obviously on the northeast is a circle shape, so I take here a signal inputter and I configure this as a circle, and this comparison basically tells me, are these two signals the same? If yes, then you're going to emit the shape a signal saying positive. So is it a circle like comparison? Yes. Okay, then I'm going to rotate the shape, so the next one obviously is not going to be a circle. So I analyze, I do the same again and say, Is this one a circle? No. So no circle going through, the third one neither, and the fourth one neither. So only the top left is going to be a circle. All the others are not a circle. Now I have here an input of circles. Okay, so I know from this setup that this one needs to be the top right, this one needs to be the top left, this one needs to be the bottom left, and this one needs to be the bottom right. Okay, so here I put in these filters, belt filter. Okay, and what I do is pretty straightforward. I basically take this shape and I tell each filter, if you get a positive signal, let it through. If you don't get a positive signal, bin it. Well, actually deviate it. So if I put a binner here, it's gonna bin those. So what this tool does is it looks at this shape and it lets only those shapes through that actually correspond. Now let's just change this shape to illustrate this. So if I go back to my signal emitter here and I would configure this, and I would basically say I would make them all circles. Now I hesitate to know which layer is which. Yes. Okay, now they are all circles. Let's see what's happening here. And all these signals are correct, and now he starts to let them all through. Now obviously again, this can be more compact, this can be more short, it can be more layout, but again, the purpose is not to have this optimized. The purpose is only to illustrate how it works. Gives you the tools to do it yourself. Now obviously what I do here is I will create a shape that I will extract the shapes that I need to create this shape. Now if I do the same for squares, or he will not let through any square, he will let through all the circles, none of these and none of these. So if I now go back to my shape and I change that again, configure, so I would just say, okay, I want actually a rectangle, I want a circle, I want this shape, and I want this shape. Confirm. So now I got one of each. So if I come back here and I look at this, and it says, okay, the top left should be a star. Is the top left a star? Yes. Okay. Now the bottom left should be this shape. Now here the bottom right should be this shape, and the top right should be this shape. So I basically filtered out all the shapes that I needed. So here the only thing I do is I bring in these shapes. I take like the rectangle here, the square, and I basically just cut it into its small pieces. And then here I'll recycle this. So now I have all the elements to basically create a new shape. So here the result is now that I have these two squares, so bottom left, top right, and if I look here, bottom left, top right. Now I need to assemble them. So I'm gonna take this all away, empty this, so here, and now I need to stack them. Now this might look a little bit confusing, but I'm basically gonna explain what is happening here. Concern is that in order to stack something, you need two belts. So here, if I basically, let's put stackers here at the end. The concern is to know which one I'm actually going to stack. So am I going to stack this one with this one, or am I going to stack this one with this one, or this with this? So you always need two. So if I only have one square, I'm not going to stack it, obviously. So I need to bypass the stacking process. Otherwise, I will have an issue of the hole being blocked because you cannot stack one. So it needs to bypass. So what I need to analyze here is how many of these belts are actually being used. So what I did is the following. I did the following. I said, is this one and this one, are they both being used? Yes. If yes, he goes into the stacker. If no, then he will merge these two. So my logic says at the end, and I will come to it. So what I try to do is I say, is this one used? Yes. And is this one used also? Yes. Then don't merge them. Is this one used? No, but this one is used. Yes, then merge it. So because I'm only gonna have one. So I will end up here either with two full belts or one single belt. Now I'm gonna do the same here, exactly the same, check. So in this particular case, I basically see this one needs to be merged and this one needs to be merged. So the idea is if I do this twice, let me take somewhere where I have some space. So if I do this twice, okay, so either I will end up with having these two lines full and this one, or I will have the four lines full if they are all full. So that are the different possibilities. So if this one is, if there's something on that one but not on that one, then I will have something here. If something is here but nothing here, I will have something here. So I will do the same here again. So again the same on these. Again a sample, so I will again check, is something on these two? If there's only one here, then he will bypass it, because I will end up with only one line. In this particular case, I got a signal here, I got none here, I got one here and got none here. So I take these two signals. So I take this signal, goes all the way here, and then I take this signal, goes all the way here. So this one goes in here and this one goes in here. Yes. So this is an AND gate. So if I have on both sides a signal, then he will go forward and he will give that to these gates, meaning he will let them through, and also he will let them through. Now if I don't have the same signal, he will basically deviate one of the two. So it's obvious that if one of them is empty, meaning I have here one of them empty, then he will not let them through. The same I do with the next two signals, so this one and this one. I do the same on these lanes. So again, I will basically have a signal here and none, signal here and none here. So he's basically deviating them also, meaning I have only one bell that is being used here in both cases. Now obviously the last case is that here are OR gates. So if I have a signal either on the left side or on the right side, so one or the other, you basically give this sign here to the next one, and the same here. So meaning if I have something coming through here and something coming through here, I'm going to have two green signals. Or if I have something here and something here, I'm also going to have two green signals, meaning I will have two belts. So he will say, okay, take these and then stack them. So here it's going to let them through. Okay, so I have here an AND gate, so if both are together, then he lets them through. I have here an AND gate, if both are together, lets them through. It's not the case, so he's gonna basically stack them. Now here I have an XOR gate. Yeah, so basically I could now stack these. So he lets these through. Okay, so let me wrap it up at this stage. So like I said, this is work in progress, so I'm myself currently experimenting with this. It is not yet finished. There is also the question, of course, of the coloring. One of the solution is that you basically get the color of the shape. It is cyan, and then if the shape comes through, it will basically detect which color it is, and the idea is, okay, deviate that one to the coloring of cyan, in this case here, but that's like the next theory on how to do this. So I might cover it, so if there's enough interest, I will cover this in the next videos. It will take me a couple of days to dig myself into. Now, if you have comments, if you have questions, if you have suggestions, if you have ideas, I'm keen to get them. And if you like this video, well, give it a small thumbs up and give it a subscribe. I would be more than happy about that. If there's enough interest, I will continue this and I will go to the next steps, meaning the finalization of this MAM of only the basic shapes, and then include the coloring, and then cover these processes in the next step. I hope this was somehow useful, and then you could basically go forward with this. My recommendation is try, experiment, play around, make mistakes like myself, and eventually you will get good at it. So that's it for today. Thanks for watching in. Cheers. Bye.